Example 4 wants us to find the polar coordinates of the point -1, square root of 3. So notice that this is given in the form x, y, and we want to figure out r, theta based off this information. So it might be helpful to first graph this on the xy plane. So -1 would be right there, and then square root of 3 is approximately 1.73. So here's 1, here's 2, and it's going to be like right there. And now we want to figure out what is this angle here, theta, and then how many units do I have to go out from this line segment, like something like that, to figure out how to get to that ordered pair on the plane. So one of the equations that we're going to need to use is we want to figure out r, and we're going to do that basically by using the Pythagorean theorem, because this is x, and actually let me switch colors here. So this is x, and then this is y, and then this is r. And we know the relationship is that r squared is equal to x squared plus y squared. And I can fill in the values for x and y. We know that x is -1, and we know that y is the square root of 3. And so that's going to become r squared equals 1 plus 3. And we get r squared is equal to 4. And then if we want to figure out r, we would take the square root of both sides and we get r equals plus or minus 2. So we're getting two answers for r, and we want to be thoughtful about that. So I'll just leave r as plus or minus 2 for now, and we'll come back later to think about that. The second relationship that we know is that tangent of theta is equal to our y-coordinate divided by our x-coordinate, and this is going to help us figure out our angle theta. So tangent of theta is equal to y, which is √3 over -1. So we get tangent of theta is equal to -√3, and we find that theta is equal to tangent inverse of -√3. So we want to figure out what angle gives us a tangent value of -√3, and that angle on our unit circle is -π/3. We can also use our calculator to figure that one out. I just want to make sure that my calculator is in radians, which it is. And so if I did tangent of negative square root of 3, I'd get -1.047, and that should be equivalent to -π/3, which it is here. Okay, so then -π/3 is somewhere right here, and now we can use this to help us think about what our r value is. Now, if r was positive, then we'd be going in this direction, but we know that our point or ordered pair is in quadrant 2, so we need to make our r value negative so that we go 1, 2, and we end up at this point here. So finally, we can give our polar coordinates in the form r, theta, or -2, -π/3. And remember, there are other representations, so you could potentially get the correct answer even though you've given a different ordered pair than this. And that concludes example 4. Example 5 wants us to express the following equations in polar coordinates. And essentially we are looking for what is called a polar equation. And in the next unit, we will be graphing polar equations. So we want to be able to take an equation in the rectangular coordinate system and convert it to a polar equation so that we are prepared to graph them in the next section. So here we want to keep in mind that x is equal to r cosine of theta and y is equal to r sine of theta, and that's going to help us come up with our polar equations. So if I make that substitution in example A here, we'd get 3 times r cosine of theta plus 2 times r sine of theta. And that is equal to 4. So if I included that extra set of parentheses to emphasize that I'm substituting it in, but really this is just 3r cosine of theta plus 2r sine of theta is equal to 4. Now, you'll find that it's common in polar equations that if it's possible, you want to explicitly solve for r. And it's very similar to the idea that generally, when you have equations like this in the rectangular coordinate system, you will often explicitly solve the equation for y. So, for example, we do 2y equals negative 3x plus 4, and then divide both sides by 2 to get y equals negative 3 halves x plus 2. So just like when we are dealing with equations like this in the rectangular coordinate system and we often solve the equation for y, the analogous situation with polar equations is you often want to solve the equation for r if possible. So what I want to do here from this step is I want to factor out an r on the left-hand side of the equation. And if I do that, I'm going to be left with r times 3 cosine of theta plus 2 sine of theta is equal to 4. And if I solve this for r, I can divide both sides by 3 cosine of theta plus 2 sine of theta. And so we end up getting that r equals 4 divided by 3 cosine of theta plus 2 sine of theta. And we have now converted this into a polar equation. Sorry, I should have drawn a better box. Oh my goodness, that is not that much better. Anyways, that's our solution for example A.